All right, this is lesson 8.3. We're going to learn how to use the sine, cosine, and tangent ratios to determine side lengths and angle measures in right triangles. So go ahead and do this quick review. Check back with your answers. Pause here now if you want to try. Read the important vocab word here. Make sure you get these ratios right. It's important when you're using trig functions. All right, so this is a review of last year. The sine of an angle, in this case angle A, so we're talking about this, is equal to the leg of the leg opposite A, the length of the leg opposite angle A, divided by the length of the hypotenuse. So in this case, A over C. The cosine of angle A is equal to the leg of the length of the leg adjacent to angle A divided by the length of the hypotenuse. So that would be B over C. And the tangent of angle A is equal to the length of the leg opposite angle A divided by the length of the leg adjacent to angle A, which in this case is A over B. Study those carefully, so make sure you know. Go ahead and pause right now and try and match this on your own. All right, so reasoning. Suppose triangle ABC is a right isosceles triangle. What would the tangent of angle B equal? Explain. So if it's a right isosceles triangle, then that means both of these are 45. And the other thing we know is that both of those would be the same. And the tangent ratio is the side opposite over the side adjacent. And in this case, if it's an isosceles right triangle, then we would be doing x divided by x, which is 1. All right, so let's use these ratios here. Make sure we can tell which ratio is which. Let's start with the sine. So the sine of P is equal to the opposite over the hypotenuse, which is, in this case, so we want to know, here's P, opposite P is 15, and the hypotenuse, of course, is along the side, which is 17. All right, then we're going to do the cosine of P, and the cosine is the side adjacent to P divided by the hypotenuse. Adjacent to P is 8, and of course the hypotenuse is 17. And then the last ratio we're going to do is tangent of P, and that's equal to the side opposite divided by the side adjacent. And opposite P is this one, 15. Adjacent to P is this one, 8. So we're going to do 15 over 8. All right? So that's just how you find the ratios. I'm going to change this problem up a little, otherwise it's exactly the same as the last problem. Change this to angle T, and each of these down here to angle T, so that we're making sure we can find the ratios with respect to angle T also. So now we're talking about this T here. The measure that's opposite of the leg, and you can pause right now and see if you can figure this out. All right, we can use trigonometric ratios to help us find things. As long as we have an angle and a side, we can find everything else about that triangle. So if we can represent a problem with a triangle. So here we have a cliff that forms a angle of 84 degrees with a lake. What that means is it's a really steep cliff like this, and then down here is a lake. All right, so if you're standing up on top of this cliff, hanging over the edge, and it says you're going to drop a rock at a height 84 feet above the water, so we're going to go like this. And when we drop the rock, it's going to go straight down and form a 90-degree angle with the water, and that's 48 feet. And we know that this angle is 84 degrees, right there. So, and what we want to know is how far out from the bottom of that cliff is the drop going to hit the water. So that's our distance x there. Now, with respect to the 48 degree or 84 degree angle, 48 is a leg, and it's the opposite leg. And x is also a leg, and it's the adjacent leg. The hypotenuse is actually this line over here, which we're not given any information about that. But we want to know x, so we have opposite and adjacent, and if you remember, the tangent ratio, the tangent of an angle, any angle, is equal to, let's just say tangent A for now, A for angle, is equal to the opposite divided by the adjacent, like that. And in this case, we're going to substitute some values in. So our angle we know is 84 degrees, and our opposite is our 48, and our adjacent is our x. We now have a proportion. We can think of this as tangent of 84 to 1, and we can actually use our calculator to find the tangent of 84 degrees, get a value for that. Then we can use cross product property to solve for this. So I'm going to get my calculator here. All right, what I need from my calculator is the tangent of 84 degrees. And the tangent is, we can just push the tangent button. Oh, we got to do something here first. We have to set our mode to degrees. So press the mode button on your calculator, find degree, press enter. Then we're going to do the tangent of 84. Now we're talking 84 degrees. And enter, and we get that number, 0.9514. And I'll just put that in here. So instead of tangent of 84, we can write 0.9514 over 1 is equal to 48 over x. And then we'll use cross multiplication here, so we get 0.9514x is equal to 48 over 1. So we can see that we need to divide by that tangent of 84, both sides. So we need 48 divided by 0.95, and I'm going to use my calculator to do that. I'm just going to do 48 divided by, and then I'm going to use this function second and the negative sign. And that gives me my last answer, which is the whole tangent ratio. And I get 5.04. See, I put the decimal in the wrong place there. So that should be 9.514. Sorry about that. So our answer was about a little over 5, but it says round to the nearest whole foot. So we're just going to say x is equal to approximately equal to 5. All right. Go ahead, you try and do that. See if you can't spot the error here. All right, there's your answers. And to correctly find this, we need to do sine of 54 degrees is equal to W over 17, which using cross products, we get 17 times the sine. Remember, this is a ratio. 17 times the sine of 54 degrees is equal to W. And we can use our calculator to find the sine of 54 degrees, which is 0.809. And if you round that to the nearest tenth, you get 15.8. All right. here we're going to use the sine inverses to find these. We want to know what the measure of angle T is, so this angle right here. And let's just label this. We know that 7 is opposite T and 13 is the hypotenuse. So we have opposite and hypotenuse. The ratio that we can use for this one is the sine. Sine of T is equal to the side opposite divided by the hypotenuse. And we can go ahead and plug in those numbers. Sine of T is equal to 7 over 13. And to figure this out now, we actually want the angle. What we're going to use for that is the sine inverse function. And so if the sine of T equals 7 over 13, then T, the angle itself, is equal to the sine inverse of that ratio. And we can get that on our calculator this way. What you do is, instead of pressing sine, you press second sine, which gives you sine inverse, and then you put that ratio in, 7 divided by 13, press enter, and it gives you the degree back. In this case, about 33 degrees. Okay, for the next one, we want the ratio with the given information here. We have the side that's adjacent to T and the hypotenuse. When we have those two, we're talking cosine. Cosine of T is equal to the side adjacent divided by the hypotenuse. And so we're going to substitute our values for that. That would be 8 over 10. And then to find that angle, we actually have to use the cosine inverse. T is equal to the cosine inverse of that ratio, which we can write that as a decimal 0.8. And then we're going to go to our calculator and find that on our calculator. And that turns out to be about 37 degrees. All right, go ahead, you try it. And you can check back with your answers. Here's your answers, and if you use the calculator correctly, you get about, comes out 82 point, a bunch of decimals, but if we round to the nearest degree, we get about 82 degrees. All right, error analysis here. Student states that sine A is greater than sine X because the lengths of the sides of triangle ABC are greater than the lengths of triangle XYZ. What is the student's error? Well, you guys remember sines are ratios. So if you look closely at these triangles, you'll see that they are similar. And angle A and angle X are congruent. So sine of 35 is equal to sine of 35 because they're the same ratio. And if we have similar triangles, which we do here because we have angle-angle similarity, that means that the ratios of corresponding parts of those two triangles will be equal. So that's the end of the video. I'll see you tomorrow.